Welcome to the Rockwell Collins MultiScan Radar computer-based training program. Let's jump right in and look at MultiScan controls and displays. Boeing aircraft are equipped with a split-function control panel giving the captain and first officer independent control of the radar. The captain's controls are at the top and left, and the first officer's controls are at the bottom and right. Controls that are common to both crew members are in the center of the panel. Auto toggles between the radar's auto and manual modes. The letter A is displayed next to the tilt code on the ND when in auto. When toggled to manual, the letter M is displayed. When the radar is in auto, the radar's automatic threat and weather detection features are activated. In manual, the radar works exactly like traditional radar. On aircraft equipped with dual systems, the center button selects the left and right receiver transmitter or RT. As indicated by the hat symbol on the button, the left RT is selected when the button is out. The test button initiates the radar's test function. Transfer allows either pilot to select the other crew member's display settings. For instance, should the captain push his transfer button, the settings selected by the first officer would be displayed on his ND. Weather radar is, of course, all about showing weather. When the radar is in auto and weather mode is selected, MultiScan uses multiple sweeps to collect weather and terrain information, stores the information in a temporary memory buffer, eliminates the ground clutter, and displays the weather. In these pictures, note the absence of ground clutter and the thunderstorm cells at 60, 130, and 180 nautical miles. In addition, the radar displays a fourth cell that is over the horizon. The yellow arc is a pack alert function and warns crews that the cell at 60 nautical miles is attenuating the radar beam and the area behind the cell is not visible to the radar. Pack alert is active in manual and auto when cal gain is selected. One significant difference between MultiScan in auto and a traditional radar is that weather below the aircraft flight path or non-threat weather is not displayed. MultiScan uses the quiet dark cockpit philosophy. In other words, if it's not a threat, it's not displayed. Note the flight path vector on the HUD display, and also note that it's intersecting the 0-degree pitch line, indicating that the aircraft flight path is above these cells. Also note that the display shows a clean screen since the non-threat weather is not displayed. Non-threat weather is often visible from the cockpit, and there are occasions where it may appear that cells should be displayed but are not. For instance, this cell is not displayed, but is it at the aircraft altitude? How about now? The fact is that this is a post-convective cell. On close approach, it can be seen that there is no substance to the cell. In fact, you can see right through it. In addition, the cell is 1,000 to 2,000 feet below the aircraft and thus not a threat. Again, applying the quiet, dark cockpit philosophy, this non-threat cell is not displayed. A quick note on radar beam width. Although a 3-degree radar beam is pretty narrow, the fact is that at 80 nautical miles, it is already 25,000 feet wide. What this means is that even when the radar uses multiple scans, the height estimation of the cell becomes more and more coarse the further the cell is from the aircraft. So on occasion, weather that is initially visible at longer ranges may fall off the display as it approaches the aircraft, and the radar can better determine the cell heights. The Weather plus Turb mode displays weather returns and turbulence out to 40 nautical miles. This NextRad presentation shows a significant cell in southwest Missouri, which is also visible out the window of the aircraft. A blow-up of the NextRad view and the radar view shows the magenta turbulence on the radar display and its correspondence with the NextRad data. Weather plus Turb is the recommended operating mode. A nuisance turbulence alert has been observed between 10,000 and 20,000 feet in non-convective or stratiform rain on the windscreen situations. This results from oversensitivity in the turbulence algorithms and will be corrected in future software updates. If you are in non-convective weather between 10 and 20,000 feet, the turbulence indication may be ignored. Map mode displays all the information the radar sees, both ground and weather returns. The ground clutter button is similar to map mode, except it is a spring-loaded momentary function. The tilt control is inactive during auto operation. Full above and below gain is available during both manual and auto operation. Calibrated gain is selected when the triangle is at the 12 o'clock position. Let's explore gain in auto mode a bit further. A typical thunderstorm is very reflective below the freezing level. However, the top third of the storm tends to be glaciated and non-reflective. As an aircraft climbs, the radar beam moves higher in the cell and at cruise altitudes can overscan the reflective portion of the cell, resulting in inadvertent thunderstorm top penetration. In auto mode, MultiScan uses an automatic temperature-based gain to reduce this threat. As the aircraft climbs and the outside air temperature decreases, the radar automatically increases gain to compensate for the lower reflectivity of upper-level thunderstorms. So let's see how this works in actual operating conditions. This example shows a typical low reflectivity oceanic cell. With manual cal gain selected, only the core of the thunderstorm is visible. In manual max gain, the greater extent of the thunderstorm is visible and the cores are now red. In auto cal gain, the radar has automatically increased the gain as the outside air temperature decreased, providing a picture that is very similar to manual max gain and reducing the threat of inadvertent thunderstorm top penetration. Note that at cruise altitudes, manual max gain and auto cal gain are essentially equivalent. In auto, further increasing the gain above the cal position may result in overwarning and unnecessary deviations. In summary, there are two major differences between operating the radar in manual mode and in auto mode. The first is that in auto mode, MultiScan utilizes the quiet, dark cockpit philosophy, and non-threat weather below the aircraft flight path is not displayed. Second, automatic temperature-based gain increases the gain as the aircraft climbs into colder regions, resulting in a picture that is very similar to manual max gain at cruise altitude. Operation in cal gain while in auto is recommended.